Dear student of class 10, last class we finished chapter metallurgy. So today we will be starting a new lesson, that is chapter number 5, mole concept and stoichiometry. Mole concept and stoichiometry. So this chapter we will be doing. So some major portion of this chapter is not there in your syllabus as per this reduced syllabus. But then also without that concept, will not be able to do the content that is prescribed in your syllabus. And some of the portion we have already done in class 9. So let's look at a glance. That means we'll do fast revision. So Boyle's law. Some of the gas laws will go for Boyle's law. This we have already done in class 9. So what is Boyle's law? It states that for a given mass of dry gas, volume of a given mass of dry gas is inversely proportional to its pressure. That means volume of a gas is inversely proportional to pressure at constant temperature. At constant temperature, that is, V is inversely proportional to pressure. V is inversely proportional to pressure, and if we put a constant for this proportionality sign, then it will be B K by P. Then we can write it is PV is equal to K. That means product of pressure and volume is always constant. So regarding mathematical proof for this we have already done in class 9. So this is simple, this is fast, quick revision only. So what you should know from here is what is Boyle's law. Boyle's law. In Boyle's law, volume of gas is inversely proportional to its pressure at constant temperature. That means what is Boyle's law equation then? P1 V1 is equal to P2 V2 is equal to P3 V3 is equal to K. That means the product of pressure and volume should come constant. That is Boyle's law. Then what is Charles' law? Charles' law. In Charles' law, at constant pressure, volume is directly proportional to absolute temperature. Volume of a given mass of dry gas is directly proportional to its absolute temperature. So what is absolute temperature? Temperature expressed in Kelvin. Temperature expressed in Kelvin is absolute temperature. Then what is Charles' law equation? V1 by T1 is equal to V2 by T2. That means here the quotient, that is V by T, is always constant. V by T is always constant. Volume divided by pressure is always constant at constant pressure. So what is Charles' law equation? V1 by T1 is equal to V2 by T2 is equal to V3 by T3 is equal to K, that is constant. So quotient should come constant. Then gas equation, this also we have already done. So what is gas equation? Actually it is the integrated form of Charles' law and Boyle's law. This is integrated form of Charles' equation and Boyle's equation. So V, if we write these two laws together, then what you will get? You will get that volume is inversely proportional to pressure and directly proportional to absolute temperature. That means what you can write? V is directly inversely proportional to pressure and directly proportional to temperature. That means you can write PV by T is equal to K. PV by T is equal to K. That means P1 V1 by T1 is equal to P2 V2 by T2 is equal to constant. That is gas equation. This also we have already done in class 9. And regarding standard and normal temperature, that is also done. So what is the standard temperature? The temperature that is 0 degrees Celsius or 273 Kelvin is considered as standard temperature, and 760 mm of mercury or 76 centimeter of mercury or 1 atm is considered as standard pressure. So what is STP? Standard temperature and pressure. So what is standard temperature? The temperature at which the reading, the Kelvin scale is 273 Kelvin. That temperature is a standard temperature, and the pressure, where the measure of pressure is 760 mm of Hg or 76 centimeter of mercury, and that is termed as standard pressure. Then Gay-Lussac's law of combining volume. This is the portion from your class 10. Okay, Gay-Lussac's law. So what is Gay-Lussac's law? What does it states? It states that at the same temperature and pressure, the volume of gases taking part in a chemical reaction are always in a simple whole number ratio. That means the gases that are reacting, that are undergoing chemical reaction, they do so in such a way that their volume is always a whole number ratio. So at the same temperature and pressure, the volume of gases taking part in a chemical reaction as either reactants or products bears a whole number ratio to one another. That means their ratio of volume with one another is always a whole number ratio. It cannot be a fraction and it cannot be in decimal. That means I cannot say 1.5 volume of nitrogen reacts with 2.3 volume of oxygen to give nitrogen oxide. I cannot say. Why I cannot say? Because Gay-Lussac's law does not allow. Gay-Lussac's law states that whenever gases combine, whenever gases reacts, they do so in such a way that the ratio of their volume is always a whole number ratio. Let's see here. Example, hydrogen gas plus chlorine gas reacts to give 2 molecules of hydrogen chloride gas. That means here nothing is written in front. Coefficient is not there, means 1. So 1 volume. Here also nothing is there in front, so 1 volume. Here 2 is there in front, so 2 volume. 1 volume of hydrogen gas combines with 1 volume of chlorine gas to give 2 volume of hydrogen chloride gas. So what is the ratio then? 1:1:2. So what is the ratio, volume ratio of these gases? 1:1:2. 1 volume of hydrogen gas reacts with 1 volume of chlorine gas to give 2 volume of hydrogen chloride gas. Means they are reacting in such a way that their volume ratio is always a whole number. Okay, they do so. They react in such a way that their volume, the ratio of the volume of these gases are always in a simple whole number, not in fraction. We cannot write in fraction. So this is also called stoichiometry. Stoichiometry means the coefficient has to be in whole number. That is stoichiometry. And those reactions which do not follow this whole number coefficient, they are termed as non-stoichiometry. So the ratio of reacting gases and product is 1:1:2, which is a simple ratio. Then Avogadro's law. So what is Avogadro's law? At STP, that means at standard temperature and pressure, equal volume of all gases will have equal number of molecules. Equal number of all gases will have same number of molecules. For example, if I say 1 liter of hydrogen gas, 1 liter of hydrogen gas, if 1 liter of hydrogen gas contains 6.02 into 10 to the power 23 molecules, then 1 liter of nitrogen gas also contains that many number of molecules. 1 liter of oxygen gas also contains that many number of molecules. 1 liter of ammonia gas also contains. That means, this clearly means, if the volume is equal, then all the gases having same volume will have same number of molecules in them. Will have same number of molecules in them. That means number of molecules in 1 liter of oxygen is equal to number of molecules in 1 liter of carbon dioxide. So number of molecules is same. For example, 1 dozen of banana has 12 bananas. Then 1 dozen of egg will have 12 eggs. So dozen means 12. Similarly, same equal volume of all gases will have same number of molecules. For example, nitrogen gas, 1 molecule of 1 volume, you can say 1 volume of nitrogen gas will get with 3 volume of hydrogen gas, which gives 2 volume of ammonia gas. Are they in simple whole number ratio? Yes. 1:3:2. So they are in a simple whole number ratio. And this can be said as volume as well as molecule. 1 molecule here, 1 molecule of nitrogen gas, 3 molecule of hydrogen gas, 2 molecules of ammonia gas. So 1 and here 3, 1 molecule. This can also be said as 1 molecule. That means 1 volume of nitrogen gas, 1 volume of nitrogen gas, whatever number of molecules it has, this will also have same number of molecules. 1, provided there is 1 volume only. But 3 volume will have 3 times more. 2 volume will have 2 times more. If the volume is same, then only they will have same number of molecules. For example, if 1 volume of nitrogen has 1 molecule, then 3 volume of hydrogen will have 3 molecules. And 2 volume of ammonia will have 2 molecules. Got it? So equal volume means equal number of molecules. Here it is not equal, 1, 3, 2. So if 1 volume of nitrogen has 1 molecule, then 3 volume of hydrogen will have 3 molecules. And 2 volume of ammonia will have 2 molecules. Another thing, Gay-Lussac's law is only applicable for gases. Gay-Lussac's law is applicable for gases only, not for solids and liquids. That means, on the basis of Gay-Lussac's law, volume of solid and liquid is considered 0. So whenever you are doing numericals, then you happen to get solid or liquid in the reaction, in the chemical equation, in the reaction, then you have to consider volume of solid and liquid as 0, because Gay-Lussac's law is applicable to the gases only. So this is Avogadro's law, which states that equal volume of all gases will have same number of molecules at standard temperature and pressure. Then this atomicity we have already done when we were in class 7. When you were in class 7, we have already done this atomicity. So what is atomicity? It is the number of atoms present in one molecule. Okay, number of atoms present in a molecule of an element is called its atomicity. So what is atomicity? Number of atoms present in a molecule of an element is called its atomicity. On the basis of this atomicity, there are many types of elements. All metals are monoatomic elements. All metals are monoatomic elements. All inert gases are monoatomic. all metalloids are monoatomic. So metals, noble gases, metalloids are all monoatomic. That means their molecule has only one atom. Their molecule has only one atom. That means if you write Mg, it means one atom of magnesium as well as one molecule of magnesium. For example, let me take you to geography. See, Australia is continent as well as country. Australia is continent as well as country. Similarly, this one, Mg is an atom as well as a molecule, because magnesium is a metal, it is monoatomic, and its molecule will have only one atom. So monoatomic, it is composed of only one atom. That means while writing these monoatomic elements, okay, molecular formula of monoatomic elements, we write simple symbols only. For example, Ca, calcium. This is one molecule of calcium, one atom of calcium. Okay, so but while writing oxygen, I cannot write. If I write O, this means an atom of oxygen. This means an atom of oxygen. Okay, this does not mean a molecule of oxygen. No, this means an atom of oxygen. But if I write this O2, then it is a molecule of oxygen. So O2 means a molecule of oxygen. Why? Because oxygen is diatomic element. Its molecule has two atoms. Oxygen is diatomic. In class 7 I said you there are 7 plus or exactly 7 diatomic elements. They are 3 Zn and 4 In. So nitrogen, hydrogen, oxygen, chlorine, fluorine, bromine, iodine. These are 7 diatomic elements whose molecular formula can be written by writing 2 as subscript in their symbol. H2, N2, O2, Cl2, I2, F2, Br2 in this way. So these are diatomic. Then triatomic, there is so far what we know is there is only one triatomic element, that is ozone, O3. Then tetratomic, having 4 atoms in their molecule, that is phosphorus, P4. Then octaatomic, sulfur, S8. It composed of 8 identical atoms. Then this one also we have already done in class 9, relative atomic mass or atomic mass. So what is relative atomic mass? It is the number which represents how many times one atom of an element is heavier than 1/12 of carbon 12 atom. How many times one atom of a particular element is heavier than 1/12 part of carbon 12 atom, that becomes its relative atomic mass. For example, relative atomic mass of oxygen is 16 AMU, means one atom of oxygen is 16 times heavier than 1/12 part of carbon 12 atom. Okay, so this way we measure relative atomic mass. Similarly, relative molecular mass is how many times particular molecule is heavier than 1/12 part of carbon atom. For example, carbon dioxide, if I say carbon dioxide is its weight is 44 AMU, its molecular weight is 44 AMU. That means carbon dioxide is 44 times heavier than 1/12 part of carbon 12 atom. Carbon 12 means here isotope carbon 12. Okay, so relative molecular mass, that also we have done in class 9. So all these things we need for this chapter, that's why I am repeating it. Otherwise, there is no use of doing revision. So why I am doing all this is because this we need for this chapter, to do numericals in this chapter. Then gram atomic mass. It is simply relative atomic mass expressed in terms of gram. Okay, the atomic mass of an element expressed in gram, or you can say relative atomic mass of an element expressed in gram becomes a gram atomic mass. For example, what is relative atomic mass of oxygen? 16 AMU. But if you write 16 gram, that means it is gram atomic mass. And relative molecular mass of carbon dioxide is 44 AMU. But if I write 44 gram, then it becomes gram molecular mass. So what is gram molecular mass? Molecular mass expressed in terms of gram. Molecular mass expressed in terms of gram becomes gram molecular mass. So when relative molecular mass is expressed in terms of gram, it becomes gram molecular mass. Then mole concept, okay. All mole is a collection of 6.022 into 10 to the power 23 particles. So this mole exactly means a kind of a dozen. Okay, 1 dozen means 12. 1 dozen potato means 12 potato. 1 dozen mango means 12 mangoes. 1 dozen apple means 12 apples. 1 dozen egg means 12 eggs. So 1 dozen of everything can have how many particles, or how many things, how many particular unit is there? 1 dozen means 12 unit. 1 dozen of anything means 12 unit of that particular thing. Similarly, 1 mole of anything means 6.022 into 10 to the power 23 particles of that particular thing. So 1 dozen means 12, 1 mole means 6.022 into 10 to the power 23. If I say 1 mole of atom means 6.022 into 10 to the power 23 atoms. If I say 1 mole of molecules, then it is 6.022 into 10 to the power 23 molecules. If I say 1 mole of particles means 6.022 into 10 to the power 23 particles. So if I say 1 mole of anything, 1 mole of pumpkin, if I say, for example, it doesn't happen actually, mole is for smaller things. 1 mole of pumpkin, if I say, then it means 6.022 into 10 to the power 23 pumpkins. Okay, so it means 1 mole means 6.022 into 10 to the power 23 particles. So a mole is defined. How to define 1 mole or mole? A mole is defined as the amount of substance containing elementary particles such as atoms, molecules, or ions and 12 grams of carbon. So how many? First of all, how it was calculated? How many particles are there in 12 grams of carbon 12? How many particles are there? How many molecules are there? How many particles are there in 12 grams? Or since it is element carbon, so how many atoms of carbon is present in 12 grams of carbon? Taking carbon 12 isotope, then they got 6.022 into 10 to the power 23 atoms of carbon. Then they did it with 16 grams of oxygen. They got the same number, that is 6.022 into 10 to the power 23 atoms of oxygen. And they took 1 gram of hydrogen and they started counting number of atoms. Then they could find 6.022 into 10 to the power 23 atoms of hydrogen. That means molar mass. Molar mass means mass of a molecule. Okay, mass of a molecule is also termed as molar mass. So that is there. Then see, this 6.022 into 10 to the power 23 every time you can't say. It takes time to tell. So for that, they gave it Avogadro's number. Avogadro's number, MA. So it is defined as the number of atoms present in 12 gram of carbon 12 isotope, that is 6.023 to 10 power 23 atoms. It is denoted by Na or L. So Na means Avogadro number. Na means Avogadro number. It is equal to the number of atoms present in 12 gram of carbon 12 isotope, that is 6.022 into 10 power 23 atoms. So Na means 6.023 into 10 power 23 atoms, and I said you 1 mole of atoms means Avogadro's number of atoms, 1 mole of molecules means Avogadro number of molecules, 1 mole of electrons means Avogadro's number of electrons, and 1 mole of a gas means 22.4 liter at STP. That means at standard temperature and pressure, 22.4 liter of any gas can have Avogadro's number of particles, Avogadro's number of molecules. Means if I say 22.4 liter of hydrogen, how many molecules are present in 22.4 liter of hydrogen gas at STP? Then you can say it is 6.022 into 10 power 23 molecules of hydrogen gas. Similarly, if I say how many molecules are present in 1 mole of oxygen gas or 22.4 liter of oxygen gas at STP, then you can say it is 6.022 into 10 power 23 molecules of oxygen gas. That means 22.4 liter of gas at STP will have same number of molecules. That means they will have Avogadro's number of molecules. Then applications of Avogadro's law. So Avogadro's law. What are the applications? Why to learn this Avogadro's law? What is Avogadro's law? Equal volume of all gases at standard temperature and pressure will have equal number, will have same number of particles, either it is atoms, molecules, ions, whatever, but it will have same number of particles at STP, provided gas will have equal volume. If there is unequal volume, then you will not get. For example, number of molecules in 1 liter of hydrogen gas is equal to 1 liter of oxygen gas. 1 mole of hydrogen gas is equal to 1 mole of oxygen gas, or 1 volume of oxygen gas is equal to 1 volume of nitrogen gas. Number of molecules I am saying. Okay, but unequal volume will not have same number of molecules, provided equal volume is there and the temperature and pressure is kept standard. Then only. Otherwise, they will not have same number of particles. So, applications of Avogadro's law. So, what are the things we can derive? What is the use of this Avogadro's law? Number 1, it explains Gay-Lussac's law. So, what is Gay-Lussac's law? It says that volume means gases, whenever they react, they do so in such a way that there is always a simple whole number ratio between them. So in a higher application, Avogadro's law can be used for determining this molecular formula of a gas also. Then it determines the reaction between molecular mass and vapor density that we are going to do in this chapter. That means we will be using Avogadro's law for finding molecular mass and vapor density. That is there in your syllabus. It gives a relationship between gram molecular mass and gram molar volume. So this relationship is also established by using Avogadro's law. What is the relation? Gram molecular mass and gram molar volume. The relationship between gram molecular mass and gram molar volume can also be established by using Avogadro's law. So these are some applications of Avogadro's law. So maybe some portion of these things your book may not have. Okay, so you can note this. This whatever is displayed on the screen is also notes for you. Okay, you can copy this. These are the notes. Then relative vapor density. Relative vapor density. So what is relative vapor density then? Yes. So what is relative vapor density? Relative vapor density is the ratio between the masses of equal volume of gas or vapor and hydrogen under the same condition of temperature and pressure. So you can read out with me. Relative vapor density is the ratio between the masses of equal volumes of a gas and hydrogen under the same conditions of temperature and pressure, provided temperature and pressure is kept at the same condition. Relative vapor density is the ratio of the mass of volume of the gas by the mass of volume of hydrogen gas. That means particular volume of gas, mass of particular volume of gas divided by mass of particular volume of hydrogen gas is called relative vapor density. So mass of volume of the gas under similar conditions divided by mass of volume of hydrogen gas under similar conditions. That condition is to be same. Okay, then relative molecular mass of a gas, that means this. This is equal to 2 into vapor density. This is equal to 2 into vapor density. Okay. So this is the formula that we'll be using in the days to come, in the next class most probably. So what is the formula for relative molecular mass of a gas or vapor? How to find relative molecular mass of a gas or vapor? It is equal to 2 into vapor density. 2 into vapor density. That means when vapor density is given, you can find relative molecular mass of gas. If relative molecular mass is given, then you can find vapor density. So how to find vapor density? Vapor density will be equal to relative molecular mass of gas or vapor divided by 2. So vapor density Vd is equal to relative molecular mass by 2. So vapor density is equal to relative molecular mass of gas by 2. And relative molecular mass of gas is equal to 2 into vapor density. So this is formula, and I'm giving this formula today only so that you can prepare for the next class. Okay, because all this formula will be using in the days to come. Then important formula, mole and gram atomic mass. 1 mole of atom is equal to how many number of atoms? 6.022 into 10^3 atoms. That is also equal to gram atomic mass of an element. 1 mole of atom means gram atomic mass of an element. 1 mole of atom means 1 gram atom. That means if I say 1 gram hydrogen, 1 gram hydrogen means 1 mole of hydrogen. 1 gram hydrogen is equal to 1 mole of hydrogen. 1 gram hydrogen is equal to 1 mole of hydrogen. And that will have Avogadro's number of atoms. Mole and gram molecular mass. 1 mole of molecules will have Avogadro number of molecules. That is equal to gram molecular mass. That is equal to 1 gram molecule of the compound. For example, if I say 44 gram of carbon dioxide. 44 gram of carbon dioxide. So 1 mole of carbon dioxide is equal to 44 gram of carbon dioxide. 1 mole of carbon dioxide is equal to 44 gram of carbon dioxide. 1 mole of particular compound is equal to molar mass, gram molecular mass of that compound. Then mole in terms of volume. How to express mole? We express mole in terms of mass. Mole and gram atomic mass is same. Mole and gram molecular mass is also same. 1 mole is equal to 1 gm of particular atom of particular element. 1 mole is equal to 1 gram molecular mass of particular compound. Then how to relate a mole in terms of volume? So 1 mole of a gas, that means 22.4 liter at standard temperature and pressure of any gas is also called 1 mole of that gas. Means 22.4 liter of hydrogen gas is equal to 1 mole of hydrogen gas. 22.4 liter of nitrogen gas is equal to 1 mole of nitrogen gas. 22.4 liter of carbon dioxide gas is equal to 1 mole of carbon dioxide gas. Then mass of an element is equal to mass of the element divided by atomic mass, or GAW. Then mass of a compound, mass of the compound divided by molecular mass. If you have to find mass of any compound, then you can write mass of the compound divided by molecular mass. Then mass of one atom is equal to, if you have to find mass of one atom, then you can divide atomic mass by Avogadro number. Number of molecules is equal to moles into 6.022 into 10.